This conference will now be recorded.
In the live scenarios, actually the performance engineering concept will come whenever we are sending a request to the client. The request will be processed at the server side and the response will be sent back to the client. So in this scenario, in this process, we'll get the response on time. That is no issues. It's a positive response itself only. So we need not to look into anything in the time. But we'll have some other thing like it's a failure thing, like we'll not get the response on time, meaning like we may get the response in the delayed, meaning like it will take some time to process the request and then to send the request means response from the server to the client, and we'll get the timeout error also in some of the scenarios. So we have to look into these scenarios actually in the performance engineering. So what is the client server? It is a distributed application framework dividing the tasks between the client and the server, meaning like whatever we can achieve the task at the client side, we'll achieve by using maybe JavaScript or maybe some other JSON or something. And whatever we need the information from the server, that request will be sent to the server. There the request will be processed and the response will be sent it back to the client. So the server may be within the same, it could be an intranet or maybe it is an internet application. So everything will communicate through computer network or via internet. This is the client server application only. We'll just mostly look into that performance engineering concepts. So the first of all, whenever we are just facing any performance issues or before we start any project also, we'll just go for the capacity planning. What is the capacity planning? Meaning like, so if we are just going to get any new project or if we are developing any new project, first of all, we have to determine whether that existing hardware or existing softwares are just at least we can use it for our project development to achieve the client output. Whether it is achievable by using those configuration or not, we have to just look into that. And what is the capacity? Meaning like here the users also will come, like how many number of employees are required to achieve the particular target within the time frame, whatever we are getting from the client within that time frame, whether with the certain people, with the specific people, how many number of people are required to achieve the particular task, we have to just plan for that also. And we have to just check for hardware, what is the hardware sizing and what is the softwares are required, everything we have to take into consideration. This is the capacity planning. Then as I told you, like what is the RAM memory we need it, what is the hard drive we need it, and what is the processor we need it, what is the OS we need it, everything we have to just give the planning, the capacity plan. We'll just look into the capacity plan. Then when we are coming into the .NET, the main concepts are like, I'm just giving that brief main concept itself only. It's a CLR. When it is coming into the .NET, CLR, we'll just look into that. CLR meaning it's like a managed execution environment that is a part of Microsoft .NET framework. It manages the execution of programs written within the different languages. Maybe we can use that C++.NET, maybe ASP.NET, C#.NET, PC++, everything, whatever we need it, we can write in our own language. But when we are compiling that one, the CLR will take care of this one, and then it will convert that code into that Microsoft.NET Framework language. So here the CLR will be very useful in this actually. So after that CLR is done, we'll come into the JIT compilers. What are the JIT compilers will do? What CLR is doing, whatever I'm writing the code in the .NET in any one of the languages, it will come into that Microsoft intermediate language, like it's a .NET language, it will come. Then the JIT compilers will take this code and it will convert that one into that native code or to the machine language to process that request. So the JIT compilers will comes into the picture here to take that CLR code to convert that into that native code and to process the request. So here three types of the JIT compilers will have, like it's a preset, normal JIT, echo JIT. These in depth will be covered in the live sessions. Then after that we'll have some few more like it's very important concept is like stack and heap. Stack is used for the static memory allocation and then heap is for the dynamic memory allocation. Both will be stored in the computer's RAM memory. But when we have to go for the stack, when we have to go for the heap, in which scenario the information will be stored in the stack, in which scenario the information will be stored in the heap. That is also main important. If we are creating any static variables, then it will go into the stack memory. Then in the dynamic variables, if you are assigning any value to that dynamically, then it will go for the dynamic memory, like it's a heap. But is it very useful to create the static variable or not? Or always you have to go for the dynamic variables? That will be covered in the live sessions again. This is one more important concept. So based on these concepts in itself only, if we use these concepts in a better way, we'll not get any performance issues. Then after that, one more concept is like it's a multi-threading. Threading is like it's a when we are sending a request to the server. If the to process that request, if it is taking more time, the system will be ideal that time. So the user cannot wait that time. Say for example, requesting any information from the server, like it's a report kind of thing. It contains huge number of records. To process to that request, it will take more time to perform that action. So that time we have to keep in ideal state until the response we got it from the server. So instead of waiting on that, we can just create one more thread and then parallelly we can do that one more work. That is the parallel execution process, which is a multi-threading. So it will be useful whenever we are sending a request, and then if that is taking more time, then we'll go for that multi-threading concept, which will be useful for the performance improvement, which is a very good concept again in the .NET. And one more concept is like it's a garbage collector. Garbage collector meaning like, say for example, whenever you are creating any object, that time we have to allocate some memory to the particular object to achieve some particular task. So internally, the .NET framework will call that garbage collector. The garbage collector will take care of this memory allocation. The memory will be stored as three blocks in this actually. This concept I'll explain in the live sessions. But whenever we are not using that any object, if it is ideal for some time, the garbage collector will automatically destroy that object. So the garbage collector actually will be useful to allocate the memory and then to destroy the memory, to free up the memory for the future any new objects. Or else if it is a full, then again we will get the memory leakage errors or some other thing. So this is the very good concept again in the .NET. Then after that, the application deployment in the IaaS. So we are going to cover application deployment in the IaaS, and then to create the applications, and then to create that application pool, and to change the application pool or change the processor type to 64 or 32-bit based on our requirement. So the IaaS, it's like the INET, it's Internet Information Services is useful for the deployment of the .NET applications. So I'm going to teach about the deployment process also, how to deploy the published content in the server, and how to create the applications, and then how to create the application pool, and changing the application pool size, and changing the processor type to 32-bit and then 64-bit also in our upcoming sessions. When it is coming to that SQL server, say for example, whenever you are requesting some information from the server, the request will be processed at the server side itself only. Say for example, you request some information from the database. So that time you have to write some query. Inbuilt queries will be there whenever you are hitting the login button. Say for example, if it is a login screen, when you click on the login button, the information has to be verified at the server side, whether that required login information, whatever we have provided, is correct or not. And then we have to assign the particular roles to the user. So these things will be verified at the SQL server side. But to verify this information, if the query, if whatever the query we have written, if it takes time to get the information from the server, then it is very difficult to handle that one, also to monitor where exactly we are getting the problem, where exactly we are getting the slow response from the server. So that time we can use the SQL profiler also. So the SQL profiler will contain all the queries from the execution onwards, and then until the action is completed. So based on that, we can just check that based on the timing, we can check whatever which query is taken more time, and then we can take that query and then we can keep it in our local SQL server. We can just check it whether maybe they have written any unnecessarily, they are calling any functions, or unnecessarily they have written any SQL code, or maybe whether they are writing unnecessary queries also, like they are returning any count which is not useful. Like that, whatever we need it, we can just monitor, and then we can just fine tune those queries and then re-execute it again. Then after that, SQL query optimization. So for example, whenever we are writing the complex queries, for example, always rather than hitting the direct table in our complex query, if we need to get the information from the one particular table more than one time, that time we can just use the CTEs, temporary tables or table variables, and then we can get the information whatever we want from the main table. We can store it into the temporary table, like it's a CTE or temp table or table variables. And from that CTEs or temp table or table variables, we can take the data and then we can further continue on to achieve our targets. And whether we are writing any functions and then store procedures, and then unnecessarily we have written any triggers, cursors, or some other thing. Cursor is also one of the major main important concept. If we use that one in a good way, then the performance will be increased. If we are not using in the correct way, then the performance will be definitely decreased. So these concepts also will be covered, how to use the SQL queries in a better way, how to use the triggers or maybe cursors or functions and SQL stored procedures in a better way. I'm going to teach in the live sessions. Then after that, one of the main concept is like this index. In the database, indexes are very useful to retrieve the data in a faster manner. Say for example, you have a customer information in the customer table. You are requesting the customer information from the server, and you are using some where conditions, like where the customer name equal to, say for example, Suresh, or where customer ID equal to 1 or something. So whenever you are using that where condition, that time if the query is it little slow to fetch that from the table, then we can go ahead and then create the indexes based on the where conditions. But the drawbacks also are there when we are creating the more indexes in the database. Say for example, always if you are performing any crowd rules like a create, edit, delete, update on a particular table, if we are using more number of indexes on that table, then the performance will be definitely decreased again. Because whenever we are using the index, the first of all it will check for the index. It has to reset the index in a particular order, then it has to update the data or delete the data or add the data in a particular position. So to do that, it will take more time. So we have to use the indexes in a better way. Even if we are using that indexes in a better way, but still if we are getting any slowness in the response, then we can go ahead and then rebuild the index. Means like detecting and resolving the fragmented indexes and rebuild that. Means re-indexing concept is like that time it will refresh the index in the database and then it will improve the performance again. So these concept again it will be covered in live sessions. Then for the front end logic, when we are coming to that, JSON also I'm going to cover. Like the JSON is a JavaScript object notation. It is commonly used for transmitting the data in the web application. Say for example, sending some data from the server to the client, and it will be displayed in the web page or maybe vice versa. By using the JSON, here in my screenshot, it is displaying the JSON body, request body also. So in this format, when we are sending the request to the client, then the request will be processed at the server, and we can display the response in the JSON format in the client side again in the web page. So the JSON also will be covered as part of these sessions. So finally, I'm going to cover in the live sessions, like in the from the .NET, I'm going to cover common language runtimes, garbage collectors, stack, heap. If we are writing any n number of one method, if we have, it contains more number of lines code, then we have to split that method into a small functions, which I'm going to teach. Code optimization, like if it is a inline queries, if we are using, like it's a directly if we are writing any queries in the C# side, then to move those queries into the database side, I'm going to teach. And after that, I'm going to show about that link basics also. It's like a language integrated query. I'm going to show some basics, and I'm going to explain about the JIT compilers and the finalize methods in the this one constructor and destructor, and then JSON and the caching techniques and application deployment. I'm going to show from the .NET, and from the SQL Server. I'm going to show about the writing the complex queries, how to do how to write it. SQL joins also, like it's inner joins, outer joins, self joins, and whatever the useful concepts are there, that one I'm going to show. And store procedures also, how to call it, how to execute it, how to write the store procedures in a better way. I'm going to explain about it. And regarding the SQL functions also, I'm going to explain about it. And as I shown you in the demo, like SQL Server indexes, how to create the indexes, whether the indexes are there in the particular table, I'm going to show. And then if the performance is decreased and the rebuilding the index without any effect in the data or something, then I'm going to show that rebuild the index also. And then I'm going to cover that SQL Server profiler concepts also in the live sessions. So that's all from my side. It's about that 15 minutes demo. So if you have any questions, maybe you can just let me know, and then maybe I can answer.